Okay, I want to close out. This will be the last video, I believe, on all the factoring. So we finally gotten through all of these. I told you this was a very large topic on factoring. But I want to do a few more factoring binomials with cubes. And then I want to do a wrap-up note with you. I'll explain in just a second. Okay, so how do we factor binomials? By using the sum and difference of cubes formula. So let's do another one here. Let's do m cubed minus 64. All right, let's back all the way out. It's a binomial. What's the first thing I look for? GCF, that's out. If there's no binomial, if a binomial doesn't have a GCF, there's only two other things I look for. What are those two things? Difference of two perfect squares. Is this the difference of two perfect squares? It is the difference. That's two terms. That's a perfect square, 8 and 8, but that's not a perfect square. So this is not perfect square, difference of two perfect squares. Now go to cubes. And if it's not cubes, then we'll write prime. All right, is this a cubes problem? Remember, in a cubes problem, the sign don't matter. Is m cubed a perfect cube? Yes, m times m times m. Is 64 a perfect cube? Yes, 4 times 4 times 4. So this is the difference of two perfect cubes. Now remember, what are we going to do with this? We're going to put this in A spot, and we're going to put that in B spot. Okay, so put your equal sign, do your two sets of parentheses, but make your second set a little longer. Now, I'm going to write my formula underneath here first. A squared, AB, B squared. There's the formula. This is always a plus. This first sign will always be whatever's in the problem, so it's going to be a minus, and then you switch it to a plus. The first sign will always be what's in the problem, then you switch it. Last sign's always plus. Okay, so what do I replace A with? M. Minus. What do I replace B with? 4. Close your parentheses. So there's two terms in that one. Now the next one. A squared. That would be M squared. Plus M times 4, which I'm going to write 4M. Plus, and then B squared is 4 squared. And 4 squared, I will go ahead and write 4 times 4, which is 16. Now, if you want to write it just 4 squared, you can. Okay, let's do one more. All right, here we go. Binomial. First, look for a GCF. That's out. Next, is this the difference of two perfect squares? No, because it's not difference. Next, check cubes. Okay? And if it's not cubes, it's prime. So let's see, what has to happen with cubes? Sign don't matter. This has got to be a perfect cube. It is. 2x, not just 2, 2x. Is this a perfect cube? Yes. 3 times 3 times 3. So this is going to be my A, and this is going to be my B. Now do your two sets of parentheses. Make your second set a little bigger. I'm going to put my formula right up under here. AB, A squared, AB, B squared. Last sign's always a plus with the formula. This sign is whatever's in the problem, and then switch it. Now, what do we put in A's place? 2x plus, what do we put in B's place? 3. Now, be careful right here. When you get to right here, you have to square A. When you square A is 2x. Now, how do you square something? You say it times itself. So when you square 2x, it's 2x times 2x, which is 4x squared. Not 2x squared. Minus A times B. So take 2x times 3, which is 6x, plus, and then B squared is 3 squared, which is 9. Two things I want to remind you of one more time. In sum and difference of cubes, this will never factor again. I know it looks like it will, but it will not. So don't spend time trying to factor that a second time. Also remember that if you distributed this out and you check this, it'd take you right back to where you started. So all sum and difference of cubes factoring problems will have a binomial in the first parentheses and a trinomial in the second parentheses. But you cannot factor either one of those, any of those, unless you're using the formula. Okay, now what I want to do to close out this section is I want to put this up for you, and I want you to freeze it, and give me just a second, because I want to make sure I get it all up here so that you can see it. All right, I'm going to zoom out a little bit. Check again. Okay. What I want you to do, let me check one more time now. Okay, yes, you can get everything on it. All right, so what I want you to do right now is pause the video and copy all of this down. I will read through it once you get it all copied. So pause the video now. Okay, I'm assuming that you've copied all of that. Let me slide this down and let you copy one other thing. Make sure. Okay, yes. Pause the video one more time and copy this down. And if you can't read some of the words, I'll read them for you. So pause and copy this now. Okay, I'm assuming you've copied that. Now, let me come back up here and tell you the purpose in this note. The purpose in this note is this. When it comes time for your test, all of the factoring problems are going to be all mixed up. In other words, on this, when I ask you to factor polynomials on the test, I'm not going to tell you which method to use. I'll just say, factor the following polynomials, and I'll give you 6 or 7, 8 problems there, and they're going to all be mixed up. So what this does is, this helps you organize your thoughts on, whenever I'm factoring a polynomial, what do I do? What do I think about first? So this is going to help organize your thoughts. Let me explain what I mean. Okay. So let's suppose I gave you a test on nothing but factoring. And I said this: factor the following completely. Suppose I said that, factor the following completely. And I gave you the test. When you look at all those problems, what do you do in your head when you're trying to go through this? All right, so let me talk to you about how to do that. The first thing you do when you're factoring a polynomial is you look at the problem and you see how many terms is in it. Now remember, I told you when I give you a polynomial to be factored, it's going to contain how many terms? Either 2 terms, 3 terms, or 4 terms. So, when you look at that problem, you ask yourself, okay, how many terms is here? Here's why you do that. Depending on how many terms it has in it, depends upon which techniques you use. For instance, if it had 2 terms in it, would you try grouping? No. If it had 4 terms in it, would you try the Brew method? No. And so certain methods only apply to polynomials being factored that have a certain number of terms in it. So the first thing you ask yourself is, how many terms does it have in it? So that's why I broke this up into binomials, trinomials, and 4 terms. Now, here's what you do. Suppose the first problem on the test had 2 terms in it. Then here's what you have to look for. That shouldn't shock you. Always check for a GCF. So if it's a binomial, the first thing you check for is a GCF. Now, if it's a binomial and it doesn't have a GCF, what do you do next? You check for 2 things after GCF. What's the first one? The difference of 2 perfect squares. Remember, it had to be 2 terms, had to be difference, perfect square, perfect square. We did some of those back in the last video. If it's not difference of 2 perfect squares, what do you check for after that? Sum or difference or sum of 2 perfect cubes. Now this is where you have your formulas, your AB formulas. We just did those. But you have to see if it's sum or difference of 2 perfect cubes. So on binomials, you only check for 3 things: GCF, difference of 2 perfect squares, sum or difference of 2 perfect cubes. And that's the order I check them in. Now, what if it's a trinomial? That's the biggest of all these families. If it's a trinomial, as always, you check for a GCF first. Secondly, after you check for your GCF, then there's 3 things you have to check for after GCF. 3 things on trinomials. Number 1, see if it's the easy case. We've done like this. Number 2, see if it's a perfect square trinomial. I gave you the guidelines on how you can tell if it's a perfect square trinomial. There was 2 guidelines, and we did some of those in an earlier video in 5.7. Matter of fact, the first video in 5.7. And then, if it's not a perfect square trinomial, and it's not the easy case, a last resort, I always do the Brew method, or the bottoms-up method. So those are the things you check for with trinomials. Now, if it's 4 terms, you check for a GCF, and then there's only one other option on the table, and that's grouping. Now, in order to do grouping, you have to know your 3 steps to grouping. If you'll go back at the very beginning of section, or no, it's not at the beginning, about the middle ways of section 5.5, I gave you the steps to grouping. So you'll have to memorize your formulas for the cubes and memorize your steps for the grouping. That's how you determine what process to use. Now, I've closed off here with just a few notes, a few reminders. Number 1, always check for a GCF first, as if I hadn't said that enough already. Remember, your GCF can be a number or a letter or numbers and letters. and it can be numbers, letters to powers. So your GCF can be a 8x to the third, y to the fourth as well. So in every problem, when you factor it, that is the first thing you always check for. Secondly, if it does have a GCF, bring it out. But if you bring out the GCF, make sure that what you have left won't factor again. That's what this second note is. Make sure you factor it completely. So in other words, just because it has a GCF, and you got your GCF and your parentheses, and this stuff may go on down and break down again. So always make sure before you leave a problem that you ask yourself, can I factor it any farther than the way it's been factored? Next, this is the big one, is remember, you can always multiply your answers out to check them, just by using the distributive property or the FOIL method. So you can always multiply answers out to check. Number 4, remember, there is no formula for the sum of squares. There is the difference of two squares. X squared minus 16 factors. But x squared plus 16, there is no formula for the sum of squares. Now, on cubes, the sign don't matter. But on perfect squares, it has to be difference. So the sum of squares is prime. And then, not only that, don't completely rule out that a problem can be prime on test. We looked at some easy case trinomials that were prime. We looked at a problem where we tried to factor it by the Brew method, and it was prime. So, problems can be prime. Now, when it comes time for your final, no, I'm not going to give you 6 or 8 problems on the final and 4 of them be prime. So, on the final, I'll probably give you about 6 or 7 factoring problems, and one of them may be prime. But the whole purpose on the test, on the final, part of the final, is to see if you know how to factor. So it'd be pointless for me to give you a whole bunch that's prime then, for that reason. Okay, so this completely concludes the topic on factoring. We started out factoring in section 5.5, and we went all the way through GCF, grouping, trinomials, the easy case, trinomials by the Brew method, trinomials by the perfect square trinomials. And then we went into binomials and talked about difference of two perfect squares and sum and difference of two perfect cubes. So that finishes this topic, but this, as I told you at the beginning of this section 5.5, these 3 sections are the single most, if I had to pick 3 sections in this entire course and say these are probably the most, they're all important, so don't misunderstand what I'm saying. But this topic on factoring is probably one of the most single important topics that you need to carry with you going from the intermediate algebra course into the college algebra course. Because factoring is not taught again. And when you get into that college algebra course, it is assumed, that you know how to factor binomials and trinomials. So make sure that you keep your notes with you and make sure you really practice and learn this process. This concludes the topic on factoring. This also concludes section 5.7. So what we will do now in the next video is we will begin in section 5.8 with our next video.